Okay, we're going to talk about even and odd functions. If I get this straight. All right. Okay, so the technical definition of an even function is if f of negative x equals f of x, then you have an even function. But what does that mean? Okay. What it means is, well, first let's talk about the easy test for an even function. To have an evened function, and remember this, we're not just talking about the degree. Every term here for an even function has to have an even degree. So let's say I have f of x equals x squared plus 1. And we need to know if that is an even function. Well, it is an even function if both terms are even. Now we can see that this term is an even term. What about 1? Is it an even term? Well, what's the degree of any constant value? Remember, we could have an x to the 0 here. It's invisible unless we need it. And 0 is considered an even number. So both terms are even, therefore f of x equals x squared plus 1 is an even function. And now let's test it with the definition. What it's saying here is, say I put in a 2. Well, if I put in a 2 into this function using direct substitution, I'll get a result. If I put a negative 2 into this function, I will get the same result. Let's try it. So if I substitute 2 squared plus 1, 2 squared plus 1 is 4. 4 plus 1 equals 5. So if this is truly an even function, I should be able to put a negative 2 in and get the same answer, 5. Let's do it. Negative 2 squared plus 1. Well, negative 2 squared plus negative 2 squared is 4, and 4 plus 1 equals 5. So that's the test that this is an even function. Now, what does that look like graphically? Well, I've got x2 plus 1. I made a table here, and it turns out that an even function is symmetrical to the y-axis. So an even function is symmetrical to the y-axis, and that is the graphical proof of that. So it's symmetrical to the y-axis, and of course one of the easy tests is to say, are both terms even degrees? Yes, they are, so it's an even function. And then when I plug in a value, I further prove that it's an even function. I put a 2 in, I get a 5. I put a negative 2 in, I get a 5. All right, let's talk about odd functions. Odd functions, the formal definition of an odd function is f of negative x equals the opposite of f of x. And I think, that's potentially confusing, but we'll see what that means in a moment. First off, just like even functions, for a function to be odd, all the terms need to be odd. So let's take this function, for example. This term is odd because it has a third degree exponent. This term has a first degree exponent. Both numbers are odd, therefore the function is odd. Now let's do this test according to the definition. And let's try 3. If I put a f of 3 in, what do I get? Well, let's see. We got 3 to the third power plus 3. That equals 27 plus 3. That equals 30. If this is an odd function, I should be able to put the opposite of 3 in here, which is negative 3. And I should get the opposite of this answer, which would be negative 30. And if that happens, then this is truly an odd function. So let's see. And actually, this would be a minus 3, wouldn't it? If I'm plugging in a negative 3 for x to the third and a negative 3 for x. Okay, here we go. Negative 3 to the third power is negative 27 minus 3 equals negative 30. So an odd function works by putting a number in, evaluating it, getting an answer. If I put the opposite input in, I should get the opposite answer, and that's what happens. How does it look graphically, however? Look at that. An odd function is not symmetrical to the y-axis like the even function. It's symmetrical to the origin. So once again, I did a t-table here, 0 and 2 points to the right, 2 points to the left, and plugging those points in and evaluating for y, I get a function that's symmetrical to the origin. So that's graphical proof that it is a odd function. Now, what about neither? Something that is not even, is not odd, is neither. Well, here's a great example here. Let's look at, say I have f of x equals x to the fourth plus x to the third plus 1. Okay. Well, this term, x to the 4, is even. But this term is odd. And of course, if you remember, every constant value would be a x to the 0 degree, which is even. So I have a mix. And whenever I have a mix of even and odds, then I know it's neither. And let's see, do I have the proof of that here? Yeah, let's do that. Let's say I have f of 1, okay? So 1 to the 4th power is 1. 1 to the 3rd power is 1. And then we had the plus 1. 1 plus 1 plus 1 equals 3. But what happens if I put negative 1 in? If it's even, I'd get a 3. If it's odd, I'd get a negative 3. Let's see what happens. Negative 1 to the 4th power is 1. Negative 1 to the 3rd power is negative 1. And then, of course, we had our constant plus 1. 1 minus 1 is 0. 0 plus 1 is 1. So now I have two results, a 1 and a 3. So we don't have the same answer. We don't have the opposite answer. That means this function was neither. Okay, so you may want to watch this video more than once to try to understand the concepts, but to sum it all up, if a function is even, you will have you can put any input in and the opposite input, and you'll get the same answer. With odd, you can put an input in, an opposite in, and you will get the opposite answer. And of course, the easy way to evaluate these for even, ask yourself, are all the terms even? If they are, the function's even. For odd, are all the terms odd? If they are, then the function's odd. If you have some mix of even and odd terms, the function is neither. I hope that helped. Remember, you're doing 2.1, and good luck. See you on Monday.